Some of y'all are going, oh no, binary again. Well, it's not going to take too long. So anyways, if this was all ones all the way across, excuse me for not formatting it right. 1, 2, 3, 4, 5, 6, well, whatever, right? Something like that. I think that's lined up. The way you figure out what that is, besides popping open Windows calculator, which has, you know, a programmer's mode. The Mac calculator may have the same. If not, you could install one from the App Store that would. But anyways, what is this? It's 1 times 128 plus, where'd I get that? That to that. What if that was a 0? Then there are no 64s, right? So it's 0 times 64, but I'm just going to leave that out. Plus, and in the interest of times, I'm going to stop saying 1 times each time. And so that's just 32 plus 16. Pretend 8's a 0, so I'm not going to write down. So it would be 128, 32, 16, skip the 0, plus 4, plus 2, plus 1. And if you added all that up, it'd be whatever it was. But instead, we're just going to add them all up, right? So that's 64, 32, 16, 8, 4, 2, and 1. If I was a math genius, I'd be able to add them up in my head instantly. I'm not, but I happen to know that all that adding up is 255. So if I ask you, like on an exam, to prove that that's equal to 10 in base 10, right? It ought to be easy. Notice I'm not asking you to calculate, I'm just asking you to prove it. Right? Because I don't care if you add the numbers up right. You know, if you added those up and you got 254 or whatever, you know, so I'm not asking you to do the conversion, I'm just asking you to prove it. Well, why is that? It's because the powers are 1, 2, 4, and 8. So, are there any 8s? Yep. So that's an 8. Are there any 4s? No, there's no 4s, right? Because there's a 0 underneath the 4 column. And I had this reduce one student to tears because they didn't get it. And so if you're having trouble with it, that's okay. Hopefully it's not too bad. 1 times 2. If you need extra help on it, send me a text message and I'll link you to a video on YouTube that'll hopefully have a better shot at explaining it than I have so far. There is a 2, right? So I'm just going to ignore that 0 there because who cares? Who cares about the zeros? What we care about are the 1s, right? And that's equal to 10, right? And then if I ask you to prove that 1, 1, 1, 1 is equal to 15, you do the same thing. You just write 8 plus 4 plus 2 plus 1. I know I launched Camtasia. I don't see it running. Here it is. Okay, good. It is running. Why don't I see it? All right, there it is. Okay, hope that makes sense. So about looping. Looping to solve that rolling 3 dice 6 times business. How would we do that? What we would do looks like we're on lecture LM. File new. Lecture M. We're supposedly on chapter 5, but I'm doing a bit of review considering that the exam's coming up on Monday. For some reason I gave y'all the date of, I don't remember what, but it happened to be a Tuesday. Y'all aren't expected to be here on a Tuesday, right? So it's the day before. It's a Monday when you get back. So we'll do a more complete review. One thing you ought to just work on, though, is making sure that you do the unit tests. Some of the questions are just drawn directly from the unit tests. All right, so anyways, we're going to define a function that rolls dice. And I don't know how fancy I want to make this function. Let's do it easy the first time. I'm going to add an import function that rolls dice. I could just do import random, but then when I want to generate a random number, I have to type stuff like this. Randint. I have to type in the name of the library and the function. I can shorten that by doing this. From random import RENDINT. That brings in the dice function and we don't have to prefix it with a random dot every time. Either works totally. Don't go back and change your homework just because you did random dot randint. Okay, so let's define a function called roll dice. It's just going to take 3 dice and return them. The values are between 1 and 6. So D1 is equal to randint 1, 6 in parentheses. Notice that if it was a range statement and you wanted to count from 1 to 6, you'd actually have to make that a 7. I really apologize for that. I didn't invent the language. I know. I see why they did it, but anyways. And then D2 is the same thing, so I just did a quick sleight of hand copy paste. D3 is the same thing. Not a copy paste. Total is equal to those 3 dice rolled together. And then return the total. It's called a fruitful function. This textbook calls it that, and I've seen the term before, even though it sounds kind of silly. But it's a fruitful function because it returns a value. If a function doesn't need a return value, like all it's doing is printing, then it's not called a fruitful function. You don't have to put a return statement on it. Not that it hurts it. You could just put it empty. Don't type this, right? Empty return statement, and that means don't return anything. Okay, so if we were supposed to do this 6 times in a row, that's about time when you want to do a loop. So, oh, by the way, somebody did the coolest thing. I have never seen that before. They used underscore as their loop variable. That's cool, and it's strange, and I've never seen that before. I don't really particularly recommend you do that in professional code because it will make other programmers' eyes cross probably. But it's cool. You know, so if you wanted to do it that way, I'm going to go back and change it like to an X. But anyways, that means count from 0 to 5, because if you leave off the first number, then it starts at 0, and 0 to 5 is 6. Remember, computers start counting at 0, so 0, 1, 2, 3, 4, or 5. I actually have 6 fingers up there. Anyways, I'm going to change that to an X as promised. All right, so now we just need to call roll dice, and we need to print the results. Joni did something cool where she printed out the colors of the dice. You know, now some people have like entire jarfuls of dice because they're dice collectors. Guilty as charged. So anyways, I thought that was fun. Anyways, let's get the roll. We could just call it total, right? Equals roll dice, parentheses in parentheses, and then print that total. What if we wanted to print the number of the roll? We wanted to say roll 1 equals, roll 2 equals, roll 3 equals. If we did that, then we'd probably want to start X at 1 so that, you know, it wouldn't tell the user that this was roll number 0 because users don't think like computers. So we're going to change this to go from 1, 7, so it'll actually count from 1 to 6. Then we can print out roll X total equals total, something like that. So print, parentheses, quote, roll, end quote, comma, X, comma, and you don't have to space it out like I do. It's just to make sure it's real easy for people in the back to see where my quotes end and my commas begin. Equals, or if you like the word equals, why not? End quote, comma, total, in parentheses. So for those of y'all who like copied and pasted the code 6 times, which is a totally legit way of doing it, considering what we knew at the time. So you had like 18 statements, you know, plus a printing out of the total, so that was like 4 lines times 6, 24 lines of code. We have dramatically shortened that, and we have hopefully made it more comprehensible as well. If you can read what a function is and you can read what a loop is, then you get what that is. That's the end of our program. By the way, some folks are still saving their code into the Python 37 directory. I swear that'll break your Python install at some point. If you insist on doing that, and I'm not being, I'm not saying you're obstinate, it's just real convenient to save them there, right? And sometimes you forget to save them there. For heaven's sakes, never call your program math. If you save your program and you call it math, it could totally break Python. Or if you call it turtle, anything that could be imported up at the top, you do not want to call your file name that. Actually, that could break the code anyways, even if it wasn't saved in Python 37, but you can get to the point where if you launch idle, it just crashes because you saved into it. But don't save your program with the name of math.py or turtle.py or random.py. Since we're calling them lectures by days and the homeworks, with a prefix homework in it, I'm sure nobody has hit that. But folks have managed to corrupt their Python install, and it can take quite a while to figure out what went wrong. I kind of know now where to look. So anyways, here I started to save it in that directory. That was dumb. Let me put it in the right directory. Did I see a hand asking for help or? Oh, no, just asking. Oh, okay. Yeah, cool. And there we go, right? We might go, well, that's no fun. I wish we had printed out all three numbers, right? We could make it like that if we wanted to. We could make the printing happen in the die roll program. I think I'm going to leave it as is, though. What if you wanted to print out the three numbers? You just have to stick a print statement right here above the return statement. Going to make the output a little bit sloppier maybe, but I think I'll go ahead and do that. I like seeing what my dice were, right? So above my return statement, and this is just for funsies so I can see what each roll was. Like if it was the same thing every time, it always added up to 12. I'd be curious if the dice were always the same or if they just miraculously added up to 12. Let's put print parentheses quote, dice, end quote, or dice equals, end quote, comma, D1, comma, D2, comma, D3, in parentheses. That'll print them all out. And there we go, right? And in my mind, that makes the output kind of sloppier. I don't know. So we could print out the total right there and skip the fact that it's roll 1, roll 2, roll 3, and so on. But I've kind of visualized that it works. Maybe I'll comment that print statement out now. Right, I've eyeballed it. The programmer's confident that it works. This particular game doesn't insist that we print out the values of the dice. I don't think that was in the assignment. So I'm going to comment that print statement out. But I am going to add a print statement up at the top telling the user what this does. Certainly do not go back and revise your program assignment if you've already got full credit on it. There's no reason to upload it again unless you just really feel like it. Print rolling 3 dice 6 times. And there we go, right? Okay. So loops are cool, functions are cool, can save yourself some duplicate coding. We didn't have to copy and paste this D1, D2, and D3 6 times. Imagine if it was going to repeat for 100 times. Like if you change this to 101. I would not want to have to copy and paste that code 100 times. There we go, right? I'm going to change it back to 6 just because that was the assignment, but could do that. And we could get all fancy and calculate the average and stuff like that, but that wasn't part of the assignment, so I'm going to leave it alone. Anybody get any typos you want me to come eyeball?
Figuring mine out.
Good deal, good deal. All right. Let's go back and look at the PowerPoint. Using loop. Advantages. Fewer errors. I would say that's true because if you get your function to work or you get your loop to work, then, once you've proven that it works, you don't have to worry that you made a typo on the 17th copy and paste or whatever. Less time required for design and coding. Well, I suppose once you start thinking like that, I don't know about the less time required for design. It's pretty easy to go in and copy and paste 6 times, right? But that's called kind of brute force programming in a way. You have a chisel, and so, what do they say? If you have a hammer, everything looks like a nail. It's a good idea to use the right tool for the job. Okay, let's just go with it. If the unit quiz asks you if it's true that it takes less time to design and code to use a loop, sure. Shorter compile time. Well, I suppose if the program is shorter, maybe it runs a little bit faster. I'm not strictly convinced that that's true with Python, but whatever. So a loop is a structure that repeats actions while some condition continues. In this case, this is not an indefinite loop, meaning that it doesn't keep repeating while something is false. It sort of does behind the scenes because it keeps repeating while x has not reached 7. Right? But it's a definite loop because it counts a definite series. Instead of being while user wants to repeat equals true. We're going to flowchart. Wait. Let's mention this. To control the number of repetitions, you use a loop control variable. If you want something to repeat an infinite number of times, you don't have to use a loop control variable. You just do while true. But a loop control variable is that. So, in the example above, x is the loop control variable. Appreciate the fact that most of y'all type along. I have a class where only 1/3 or 1/2 of the people type along, and a lot of the other people spend a lot of time looking at their phone, and I kind of dread how their exam's going to go, but we'll see. Wise use of your time. And I know that some people have difficulty typing, but I'm not convinced that 1/3 of the class has difficulty typing. Anyways, so that's the loop control variable. And in general, loops continue to repeat until a condition becomes false or a break statement is encountered. Loops continue while a condition remains true. And I know that I said until a condition becomes false, but that's the same thing, right? And in parentheses, or a break statement is encountered. What does that mean? If I put a break statement right, don't do it. Put a break statement right after that print, it only repeat one time. Because as soon as it hits a break statement, it kicks it out of the loop. It's like being grabbed by the bouncer and being thrown out of the theater. So, break statements can be useful, like if an error is encountered, or if you're just trying to roll dice until you get an 18, you get 3 6s, and you think that's so cool, you want to stop the rolling. We may have used a break statement in our guessing game. I think we did a guessing game. I don't recall if we used break or not. Not convinced we did. Anyways, we could have. Or if you have a while true loop, which is an infinite loop, there'd better be a break somewhere down inside it to kick it out. Otherwise, it really is an infinite loop, and you don't really want infinite loops. All right. And by the way, my little rant earlier doesn't mean that you have to type everything in, and that I think less of you if you do. But if you're watching your phone too much, then I begin to worry. So, it only ran once because of my break statement. Obviously, I don't want that. What if I wanted to make it stop as soon as we rolled an 18? Well, it had better roll a lot more than 6 times. We could change that to make it roll like 600 and 700 times or something like that. But we would word it like this. And again, you don't have to do this. It certainly wasn't part of the homework, but if you feel like it. If you know, total equals 18. That's our magic condition. That's going to stop it. Break. The break has to be indented. The if statement has to have a colon, as always. And I'm just going to make it loop like 70,000 times. It's not going to take that long, right, until for us to get a 3 6s. That should occur once every 6 to the power of 3 times, which is certainly not that large. Right? This time it took 34 rolls to do it. Let's run it again, just out of curiosity. Sometimes it'll take a lot more. That time it took 89 rolls. You know, and it's possible it could do it on the first time. I don't know how many times on average it would take. That doesn't look like 6 times 6 times 6 to me, so I think my estimate was off. It did it on the first time. Okay, what do you know? Anyways, all right, I'm going to go, I don't know. I may just leave that, right? But then my print statement is wrong. Rolling 3 dice until 18 is rolled. And I can make this 1,000,000 just to make it absurd, right? 6 zeros, 3, 4, 5, 6. From 1 to 1,000,000 minus 1, because that's what that really means, right? All right. Obviously, we're kind of out of scope of what the homework was, but hopefully if you were actually planning on turning it in, you could change it back into the homework, or you took a, made a copy of it, backup copy before you got that far. And if you didn't type all that, that's fine. Okay, so anyways, 32 times. Now, if it's supposed to repeat infinitely, I shouldn't, the only reason to use a for loop would be able to print which roll it was. I could have just made it a while true loop, because it's supposed to repeat infinitely. And while true will repeat until a break statement. Books don't show while true. Some textbooks don't. Then this is one of those that's the case. But it's a useful concept anyways. So repetitions are controlled by a counter or by a sentinel value. And we've talked about sentinel values. Keep repeating, like enter a test score or -1 to quit. That -1 is a sentinel value. Kicks them out at that point. A definite loop executes a predetermined number of times. You usually use for loops for that, such as a counter-controlled loop or a counted loop. Those are our for statements. The loop control variables are altered by either incrementing or decrementing. If you're counting backwards, you would decrement. That means subtract from. If you're counting forwards, you would increment. Your counter is a numeric variable. They say it usually starts with 0. Good enough, but the user doesn't want to see 0. I guess we could just add 1 to it when we were printing it out. The only limit about for statements is that they deal in whole numbers only in this language. That's not true of other languages. So if you wanted to go by 0.5 each time, you'd have to choose another structure other than a for loop. You'd use a while loop, and you would initialize your variable to 0.5, and at the bottom of it, you would do, variable plus equals 0.5 to add 0.5 to it each time. I was going to make us go back and flowchart that, but now that there's a break in it, I'm not fond of that anymore. Because flowcharting a break is kind of outside the scope of where we were. Well, we'll see. In the program's mainline logic, 3 steps should occur. You provide a starting value for the variable, you test the loop control variable to see whether the loop body executes, and you alter the loop control variable within the loop. Let's rewrite this looping business so that it uses a while loop. So I'm going to initialize the variable to 1, and then it's going to say while x is less than equals 6. This will probably be the one we flowchart if we have time. So x equals 1. I'm going to add a comment. This is our loop control variable, also known as our counter. while x less than equal to 6, or you could say while x less than 7, and then it'd be kind of like a range that goes one past. Let's get our total. Total equals roll dice, parentheses in parentheses. Let's print that total. Print total. I guess we could print out x, right? Print x comma total, just so we see 1, 2, 3, 4, 5, 6. And then we need to increment. I almost forgot to do this. Increment the x variable. What are we going up by each time? 1. So after our print statement, x plus equals 1. So you got to initialize. These are the 3 steps in a loop. You got to test or have a condition, and you have to have an update. Every loop has one of those things, or all 3 of those things, except for a while true loop, which doesn't have an initialization or an update. It just has a condition. It doesn't seem like it has a condition, but it has a condition later down inside of it that breaks like this. But for the most part, this is a textbook loop. Even statements like this, for loops, have all 3 things. They're just all combined up in one, right? Here's the initialization, setting it to 1. Your condition is while it's less than 1,000,000, and your update is the update happens automatically just because it's a for loop. So it has all 3 things. So loops generally initialize, condition, update. I tack the word generally on because, as I keep mentioning, a while loop instead has a while true. Excuse me, a while true loop has a while true and a break. So that's just a bit different, but it still has a condition. Just doesn't update. Something has to update, though, for it to figure out the break. Anyways, I'm not going to tie myself up into knots trying to explain something that's not in a book. So a nested loop is a loop within a loop. Did we talk about nested loops last time? If I open up our... If I look for the word nested, am I going to be happy or sad? All right, we're going to do a nested loop. So, for x in range, 1, 11, no, that's too high. I don't want it to print out 100 lines of code or output. I did not need that parentheses before the x. Sorry, I keep slipping into what's known as a C syntax, which is used in Java and C++ and everything. For x in range 1, 4, that's actually going to go only 1, 2, 3, right? 1 to 3. For y in range 1, 4, in parentheses colon, same business, that's 1 to 3. Print x comma y comma x times y. We're just kind of making a multiplication table there. And I'm going to end that loop. So that's kind of the end of the for loop. And I'm going to kind of end that one. Again, the comments are optional. I certainly didn't do it on that while loop up there. By the way, that very top function we wrote, the very top module, could have been written as a loop as well, right? Because it has some copying and pasting as well. D1, D2, D3. It could have just been a loop. And then we could modify that easily so it would roll 7 dice and add them up or whatever. I don't want to go back and retroactively modify that. Yes, sir?
So the x in this new loop that you just wrote, does it not refer back to the x that you just initialized for the last loop?
Good question, good question. This language lets you reuse variable names. And when I do it like that, it erases the former value and it redefines its type. So like even if that was a string, it's okay to do that in this language. In a lot of other languages, that's not legal. And so it's possible that I shouldn't be showing you how to do that. It's possible that I should be giving new variable names for everything. So if that was the case, I would make this say for x1 or x2 or something. And then just for clarity, I might make that say y2. And then I would change this to say x2, y2, x2 times y2. Does that make sense? It's pretty much okay in this language, but that doesn't mean that I want to teach you bad programming habits. So good call. And the question is, does this x refer back to that one? No, we are redefining it, which in this language is okay, as long as you don't care about what x was up here, right? If we wanted to check out what x was from that prior calculation, well, we just completely erased it. Not anymore, because we changed it to x2 and y2. All right, and so there's our calculation table. Looks kind of weird. Oh, this is when we repeat it 6 times. I should put a blank line in there to make sure that it's really clear what it did, right? So I'm just going to print a blank line. Why? So that I can just tell the difference between the sections. There we go. Right? And so there's my little cute multiplication table. The outer loop controls this first variable. This inner loop controls the second variable. And notice that this inner loop repeats all the way from beginning to end before the outer loop repeats once. Right? So it says 1, 1, 1, 2, 1, 3. Because y is going up by 1. It's just like clocks, right? Or an odometer incrementing or whatever. But the minutes iterate from 1 to 60, but the hours iterate from 1 to 12 or 1 to 24 if you're like military time. So that's what's going on. The inner loop has to continue before the outer loop can iterate one more time. So the inner loop is stuck here repeating 3 times, and when it's finally done, it comes back and it checks the outer loop. So that's an example of a nested loop. Which? If we felt like it, we could modify our print statement. Print parentheses, quote. How about \n to generate a blank line? That's what \n does. That backslash is the one above the enter key and not underneath the question. And then nested loop. And then another \n to add another blank line, end quote. Like that. Okay. Anybody need typo help? Please stop me. Don't wait for 45 minutes and then need help with stuff that happened, 45 minutes ago. We all good? All right. Here's their example of a nested loop, and it doesn't show the whole thing. It shows the outer loop, but then it says that there's something called a detail loop elsewhere, which they didn't even draw, probably on the next page. Yeah, there's a detail loop defined in an entirely new module. Well, a nested loop just looks like. Let's go back and do some flow charting of our die rolling program, the one that did, just 6 rolls. So lucid chart. You don't need to make this one because I'm going to start on a brand new one. This is just what a nested loop looks like, broadly speaking. I'm not going to even show the details. I'm just going to show a decision here. And then something happens, something cool, right? Like the initialization of the variable. And then there's another loop that comes over here and does something else useful. I should just make these go off to the side. And then it repeats, right? Comes back up and does that. And then this one repeats. Now, obviously, that's simplified. It's not showing the details. I could move the process right up here to the side, other than that messes up all my arrows. But that's a nested loop. Hope that makes sense. It's a diamond indented under a diamond, just like we had a for statement indented under a for statement. You can also have nested if statements, right? Or you can nest an if inside a for. Anyways, or a for inside an if. But that's a nested loop. I don't care if we draw that. What I care about, why don't I just put some text there explaining what that is for future generations to enjoy. Here we go. Our die roller. It had two chunks of code. It had a function, a module, and then it had some main code. We didn't call it main. We didn't put a comma in main, but that's what it was. So let's define our module first. Don't have to. We could do main first and then put the modules to the right. But the module was first in the code, so I'm going to make that my first column. A module starts with an oval just like main does, except it's got the name of the module, which I think was something called roll dice. If I go back and look, yeah, it's called roll dice. You could put DEF there to make it look like Python, or you could, the book would just put roll dice without DEF. I don't mind customizing flowcharting for our own purposes, so I'm going to put DEF there. Then the next line, I believe, was initializing a variable. No, it wasn't. It was just D1, D2, and D3. Those are math statements that go in regular rectangles, called process blocks. If something is incredibly repetitive, I don't really mind putting them all into one process block. But really only if it looks exactly like it did here. Don't put more than exactly duplicate statements all in the same process block. And as a matter of fact, to discourage people from doing that, I'm going to say D1 equals random number between 1 and 6. But then I'm going to copy and paste that and draw lines between them. By the way, when you're resizing, if you hold the Alt Option key down, it tends to resize a little bit better. Not always perfectly, but okay. I'm just going to copy that and paste it because we had D2 and D3, and that's faster for me. D1, D2, D3, and then I'm going to draw lines between them. It's always slightly tedious, but doesn't take that too long. There. There. You can always zoom in by holding the control key down, spinning the mouse wheel, the command key down for the Mac users. Make it easy to draw tiny lines. And then after our 3 die rolls, what was the next statement?
Total equals?
Yeah, total equals D1 plus D2 plus D3. So that's more math, goes in a rectangle. Total equals D1 plus D2 plus D3. And the book would want us to put the word set in front of it, or at least they would if it was pseudocode. I don't care, I don't want to. Here we go. Sometimes it doesn't let me resize as easily as others. There we go. And then a return statement. A return statement looks just like that stop oval, except it has the word return in it. And in this particular case, it's returning a value. So return total. You do not have to take any time resizing your boxes at all. You know why I do it. Try to keep as much on the screen at one time. So that's our module. How do we know it's a module? Because it doesn't just begin with the word start. Now we're just going to do that simple one. Not the one that checks to see if we rolled 18 and has a break statement, just the one that goes from 1 to 6. Now this one does need a start because it's the main code. Then it had a for statement. This shows a lot of wasted space over there. Can I get rid of that? Come on. Oh, not that far. Oh yeah, I forgot. If you hold down your hand, the space bar, you can move it around like that. That's useful. All right. So the very first thing right off the back of our main code, if we went and looked, oh, we did a while loop, not a for loop. So we do need to initialize the variable. I'm going to add a comment here saying this is the main code for our flowchart, just to specify. If somebody comes and looks, why didn't you put this in your flowchart? It's because our main really starts here. If we wanted to, we could add the word start to the beginning of it, and we could add the word stop to the end of it, like that. All right, going back. The first thing in my main is going to be initializing x to 1. The textbook would show that being in a declaration block. I don't care if you put the word declaration on it or to make it match the textbook or not. So back over here, that's math, but it's not a predefined process. The shapes look the same. They're both rectangles. There, I did it again. Stop it. Alrighty. So the process block, x equals 1. Or if we felt like it, we could put declarations, x equals 1. I think that just kind of messes it up, but it is like the textbook. And I'm going to undo that. I know I've mentioned this before, but this language does not require declarations, unlike the C-based languages, C, C++, Java. I meant to get rid of that word, declarations. There we go. When you declare a variable, you're declaring its name and the type of data that it can hold in those languages. Those are more strictly typed, strongly typed. Once I declare a variable, then its type cannot change in those languages. In Python, it can. All right, now we have a loop. While x less than equals 6. While x less than equals 6. Tabbed over is where we get the value. Total equals, but this one is a process block, meaning it is the one over here to the right. If you can't get it to work that way, it's this one right here. It's the one with the vertical bars. Does mine look different than yours? Is my background here black and yours white?
Yeah.
Okay, I need to mess with that. Anyways, okay. So why is this go in a block with bars? Because it's not merely math, it's because it's calling this module. So total equals roll dice, parentheses in parentheses. The next statement is a print. We could put the word output like in pseudocode, but why not just actually put the word print? Every programmer knows what that means. Since it's input-output, it goes in a tilted rectangle, so-called quadrilateral. But rectangles are also quadrilaterals, so. All right. Anyways, there's got to be a name specifically for a tilted rectangle. I don't know what it is. Total. Wait. No, this is print. So print x comma total. And if you feel like putting the parentheses there just like you would do in Python, I don't care. Feels great. Do it. Don't gotta. After that, we increment x if my recollection is correct. See, as soon as you start resizing it, it messes up the arrows. I'm not going to fix that. Now, increment is just another form of math. You could say x plus equals 1 or x equals x plus 1. I'm just going to go with x plus equals 1 because I think that's what's in our code. And then I'm going to draw a line back to our while. And I know I've lectured before that the textbook shows it going above the while loop. I like to draw it just like that because it's less complicated. There's only one angle instead of like the 3 angles or whatever required to get it to work the other way, the 2 or 3. I think that's cleaner. Your mileage may vary. And then that's the end, so I'm just going to put a stop. And I'm just going to nudge the stop over just to make it fit. But normally I'd probably drag it all the way down underneath that bar. And that's good enough. The direction of the lines generally should be top to bottom. But we have some artistic license. Yep, that is not Arnold Schwarzenegger. That is stop. Great. You can if you want. The coloring is totally personal to you. But I tend to color the top of the bar. Where'd my stuff go? Seemed like there used to be more lighter colors. And then color where it's called, like that. And the reason those are the only things I color, whoops, I wanted that to be the same color, honestly, is because it just makes the eye zero in, right? And if I put a color on the return statements or the stop statements, it's kind of drawing it away from the real meat of the matter, which is that it's making a function call, making a module call. I've seen people color every block separate, a different color. Or all the rectangles one color and all the outputs, whatever. All right, we good to go to the next section? So this is an example. Supposedly you can just double click on the white space and it'll let you type in. Example of flowchart for module, parentheses, function, and while loops. For loops are exactly like while loops, except you just put for x equals 1 to 6, or for x equals range. The textbook would show leaving the word while off, and the textbook would show leaving the word for off. Whatever. I like putting them in there. It makes it even easier to understand, in my opinion. These are tools for us, and so I don't care if they match the rules exactly. There are some rules I want you to match exactly, specifically the shapes, right? All right. If we look at their flowcharts, they tend to be a little bit more formalized. They put all their declarations up at the top. They quite often have a block called housekeeping. Now really, quite often you couldn't do that because things that are defined inside a module are not supposed to be available to this stuff. And if it declared more than if it changed the value of more than one variable here, it'd be real hard to get those values over here. Yeah. Anyways, our flowchart's a little bit simpler, and I kind of like the way that they come out better. To me, that's what's important. This one doesn't have a declarations block and no further function calls. The same business, right? It's got an outer loop and an inner loop. Loop facts. Nested loops never, quote, overlap. I think that's even a quiz question. The inner loop always gets completely done before any part of the outer loop repeats. The total number of iterations is typically the number of inner loop iterations times the number of outer loop iterations. It can get a little bit more complex than that, but in general, if you have a nested loop like we did here, if this is going from 1 to 3 and this is going from 1 to 3, 3 times 3 is 9. Repeats 3 times 3 equals 9 times. Common loop mistakes. Failing to initialize the loop control variable. You'll see me do that all the time, but fortunately I go back and correct it, but I should take care not to do that because it always confuses people when I move back and forth. What's an example of that? And I am going to reuse a variable, and it would be a big mistake to do so. But if I want to add up all the numbers between 1 and 10, which is called a summation, if I did this for x in range, so let's change its variable name. For I in range 1, 11, so it'll go from 1 to 10. And you really don't need to add these little comments about the range. I'm going to keep doing that just to remind you. All right, and then I said total equals total plus I, or total plus equals I. And then I got back down here and I printed the total. I'm going to put \n, so it'll just go to the next line before the word total. Total equals, in quote, comma, total. It's certainly going to give me the wrong value. I happen to remember, just because I've written this program a lot, that the summation of 1 to 10 is 55. I really doubt that that's what I'm going to get. And the reason why is I did not initialize my variable. Okay, I need to change that. But anyways, right, total 61. Why is that? It should have been 55, but the total was actually set in a prior loop. 3 plus 3 is 6, plus 9 is whatever, right? And so apparently it changed it a little bit, but definitely wrong. I forgot to initialize my total variable. That's a good reason to always use different variable names. But certainly always remember to initialize your variable. Don't forget to initialize your variables. It would also want me to initialize I, but since I wrote it as a for loop, I don't have to. Also, I don't think I used I anywhere. But for loops automatically do the initialization, the comparison, and the update all in one swoop. So you don't have to initialize your loop control variable before then, but you certainly do if it was a while loop. If we rewrote this as a while loop, total equals, this time I'm going to do, I forget what it's called, factorial, that exclamation mark on your big fancy calculators, which does 1 times 2 times 3 times 4. I better start it off at 1 rather than 0, because 0 times 1 times 2 times 3, well, 0 times anything is 0. So I'm starting it off at 1. We're going to do factorial, I think that's what it's called, instead of summation. I guess I could put the word summation here. And I could have even added the word summation of my total here. I'm going too quickly. Summation in my total. I just changed that line. And now, since this is going to be a while loop, I am going to initialize my loop counter. counter equals 1, yeah, 1, because we're going from 1 to 10, while counter less than or equal to 10, colon, multiply that into our total. Total equals total times counter, or the short form, total times equals counter. I had a textbook that never showed that plus plus or plus equals stuff, and I did it in all my examples, and it really confused people. So I don't remember if this book does it that way or not. I really hope that this plus equals and times equals doesn't mess you up. If it does, just remember that this means total equals total times the counter. And then I have to update my loop control variable, or else it'll just keep multiplying 1 by 1 by 1 by 1 by 1. So counter plus equals 1. And then some output, right? Print, parentheses, quote, backslash n, factorial. Is it factorial or factorial?
Factorial.
Okay. I'm glad there's people in here to keep me straight on the stuff I should know. Factorial, factorial. Factorial of 10. I believe I wrote the word if 10. Equals, end quote, comma, total, in parentheses. You know, I like the word sum better, but sum is a function, actually. If you type sum like that, it turns purple. And in these particular examples, it'd be okay to erase our sum function and just use it as a variable, but I don't want to get in the habit of doing that. So there we go. All right, there we go. Factorial of 10. If I had been thinking again, I probably would have made that first one that rolls until you get an 18 a while loop, because then it would not have required a break statement. Let's demonstrate that one. Roll until we get a 2 on 2 dice. We need to initialize our total variable and our counter. Let's call our total roll equals 0. And what are we going to do? We're going to keep rolling until our roll is equal to 2. So while roll, and then when I say not equal, I type that as exclamation mark equals. While roll not equal to 2, D1 equals roll dice. Wait. Roll dice always rolls 3 dice, so I'm not going to do it that way. So I need to make this say roll until we get a 3 on 3 dice. In fact, I'm just going to say roll until we get a 3. And I'm not going to make this say D1. I'm just going to make this say roll. And then I'm going to print the roll. And then maybe add a print message. Print, quote, backslash n. We rolled a 3. Finally, exclamation mark, end quote, parentheses. Yeah, that one took a long time. We didn't have a counter in here to indicate how many times it took. Let's modify this a little bit to do that. So we're going to add another thing, which is going to be our counter. Have we already used a variable called counter? Yeah, we did. I'm going to ignore the fact that it's poor form to reuse variable names. At least it's the same purpose, right? So counter is equal to 1, right? I just added this line. Certainly don't add those things. Those are just to show you what changed. I'm going to change my print statement to say counter comma roll so that we can see which one's changing. I mean, you know, roll number 1, roll number 2, roll number 3. So I changed that line, and then I need to increment my counter. So I'm going to add one more line that says counter plus equals 1. Those are the 3 changes I made to my loop as it was before. There we go. Took 65 turns. I guess we could change our print statement to say how many times it took, right? I'm just going to erase it. That'd be easier. Print, parentheses, quote, it took, end quote, comma, counter, comma, quote, rolls to get a 3, end quote, in parentheses. At that time it took 69 rolls. No, it didn't. It only took 68. What's wrong? Why is this saying 69? Somebody will spot it. If I look at my code here, why is this saying... Yeah, because of that thing. So although this is counterintuitive, I'm actually going to have to remove 1 from counter. I could either do it here, counter minus equals 1, or I could just put counter minus 1 here. I don't know which one makes more sense to you. How about that? Or if we started our counter at 0, well, then we have the same problem, right? We'd have to add 1 to it in our output to make it user-friendly to user eyeballs. Okay, took like 200 turns to roll that 3. It's taken 430. Okay, wow. The force is not with me. All right, I think we're done for today. What's our homework going to be? I'm going to want you to flowchart the factorial loop and the roll 3 times loop. I mean roll until we get a 3 loop. Remember that since this uses the roll dice function, you're going to have the roll dice function as well. So whether you copy and paste your roll dice function into a new flowchart, should call it a module, but because of the module, or you just modify the one we did today to have another column, it's either way is fine. So flowchart the factorial and the roll until 3 loops. Don't forget to include the flowchart for the roll dice module. Just as a reminder, don't forget to leave off your start. So I'm adding the word start there. And your stop for your flowcharts. And you can tell where I'm going to copy and paste. I'm just going to start from there to there, but then go and also include. One thing that's kind of cool, which I didn't do, is you could, if you wanted to. Let me just give you an example, and then I'm going to undo it because it's not going to be quite right. But you could. You could take your source code, copy it, and paste it directly into your flowchart. Right? I just did a copy, and I'm going to paste, and that looks pretty lousy, but I could right justify it if I wanted. Excuse me, left justify it if I wanted to. How do you do that? You find that thing with the 3 horizontal lines, and just like using Word, left justify, right? Now I think I'll undo that, but if you want to do that in your flowcharts when you turn them in, you know, I might even give an extra point of credit because it's kind of cool. Oh heck, why don't I leave it there? Just as an example. But I need to go and get my start for this one as well, right, if I'm going to do that. And that'll be the last thing I do today. So that was here. And that's here. All right, let's make a Dropbox so you can submit whatever you feel like.